Hello friends, today in this video lecture I will discuss about 8051 serial ports. So 8051 serial port is an UART device, that is UART stands for Universal Asynchronous Receiver Transmitter. So you can transmit the data serially in asynchronous format, or you can receive the data serially in asynchronous format. Look into some of the features of the serial ports. So one is the full duplex communication. So 8051 serial ports they support full duplex communication. So they have two separate lines for transmitting and receiving the data. So it supports full duplex communication, and also it has a double buffer register. So SBUF. So double buffer register SBUF is a two separate registers. One is used while transmitting and the other is used while receiving the data. So they both have the same address, hence it is named as double buffer register. And then these serial ports they operates in 4 different modes of operations. 0, 2, 3, 0, 1, 2, 3 are the 4 different modes that these serial ports operates. And these serial ports, while transmitting or receiving the data, so they are transmitted and received at a particular rate. That is the number of bits that are transmitted per second, or the number of bits that are received per second is what we call as a baud rate. So that baud rate is programmable in these 8051 serial ports, and in some modes it is fixed. So you can have both the type of baud rates, that is fixed as well as the programmable. So baud rate is measured in terms of BPS, bits per second. And then we have several special function registers for the serial ports for configuring the different modes of the serial ports and doing some other functions for the serial operation. So mainly 3 registers are used. One is SCON, which is a serial control register that is used to select one of the modes for the 8051 serial ports, and also generate the interrupts while transmission and receiving, and some other functions. And then you have a SBuffer register, that is a serial port buffer register, and it is used to hold the data before transmitting, and that is used to store the data after the data is received. So we have separate SBuffer registers for transmitting and receiving. So and then we have a PCON register, that is a power control register. So we are not going to use the all bits of the PCON, but only one bit of the PCON register is used, that is S mode bit of the PCON register is used. So if you look into the PCON register, so in power control, PCON is a power control register. So in that you have 8 bits, and this about this PCON that we have already discussed in the 8051 architecture itself. So the bit 7, that is the S mode bit, that is used to select the baud rate for the serial communication. So when you set this bit to 1, then the baud rate is doubled, otherwise half of the baud rate is selected. So this only this bit in the PCON register is used for the serial port communication, and the rest of the bits they are used for different other functions for the power control operation of the 8051. Now let us look at the SCON register. So if you look at the SCON register, so SCON is a serial control register and whose address is 98H, and it has 8 bits. So the higher order bits, that is D7 and D6, is the SM0 and SM1, that is serial mode 0 and serial mode 1 bits. So that is used to select the serial port mode, and that is shown here. So you can use these SM0 and SM1 bits in SCON register for selecting the serial modes. So if these bits, if they are set to 0, 0, then serial mode 0 is selected. In mode 0, the serial port acts as 8-bit shift register, and the baud rate at which the data is transmitted received is crystal oscillator frequency is divided by 12 is the frequency, is the baud rate at which the data is transmitted received. and then you have 0 1 bits in the SM0 and S1, then mode 1 is selected. Then the serial port is 8-bit UART, acts as 8-bit UART, and the baud rate is variable, so you can select different baud rates by writing the proper values to the TH1 values. You can select the different baud rates for the serial communication. So that is done by writing the values 0s and 1 to the SM0 and SM1. If you write 1 or 0 1 0 to the SM0 and SM1, then mode 0 is selected. So in mode 0 the serial port acts as a 9-bit UART. So in 9-bit UART an additional bit is used for different purposes, and the baud rate is fixed in this case, that is mode 2. That is, you can use the crystal oscillator frequency divided by 64 or 32 is the baud rate used in the serial mode 2, and then setting the bits SM0 and SM1 to 1 1. Then serial mode selected is the 3, and it acts as a 8-bit 9-bit UART. It acts as a 9-bit UART, and then the baud rate is variable. So only in modes 1 and 3 you can have a variable baud rate, and modes 0 and 2 the baud rate is fixed. So these are the 2 bits in the SCON for the selection of the serial mode. So that is the D7 and D6 bits. They are used to select the modes for the serial operation, serial communication, and SM2 is the multiprocessor communication mode, and then REN D4 bit is the REN bit, that is receiver enable bit. So you need to set this bit to 1 to receive the data or receive the characters. You need to set this bit to 1, and then this TB8 and RB8 is the transmit bit 8 and receive bit 8. So this is used only in modes 2 and 3, that is a 9-bit UART mode. So modes 2 and 3 are the 9-bit UART mode, that is an additional bit is used in this 9-bit UART mode, modes 2 and 3. So this additional 9th bit is transmitted through the TB8. So the bit that you want to transmit, an additional bit, is stored in the TB8 to transmit, and then the additional 9th bit that is received is stored into the RB8 in the SCON register. And then you also have interrupt flags. So one is the TI and the other one is the RI. Once the data is transmitted completely, then it generates an interrupt called as TI interrupt. So that is on the D1 bit. So if this D1 bit is set, that means the data is transmitted completely, then it is ready to transmit another data. Whereas if the RI bit, that is D0 bit, is set to 1, that means a receive interrupt flag is set. So if a receive interrupt flag is set, that means data has received completely, then it is ready to receive the another data, or then only it receives the data from the serial buffer. So if this bit is set to 1, then it receives the reads the data from the serial buffer register. So this is about the SCON register. So by using the serial control register, you can set one of the modes, and you can transmit or receive the additional 9th bit, and then you can set the flags, interrupt flags, while transmitting and receiving the data. Now let us look at the block diagram of the 8051 UART serial port. So this is the block diagram of the 8051 serial port, and where you have 2 serial buffer register. One is for write operation, another one is for read operation, and also you have a shift register. So if you want to transmit the data, first the data is placed in the S buffer register. So once the data is placed in the S buffer register, and then apply the transmit clock to the clock signal. So once if you apply the transmit clock to the clock signal, and then you write the data to the S buffer, then it is transmitted over the TXD line. Whereas if you want to receive the data, then the data that you want to receive is stored into the, first it is received to the shift register, and then it is received at a baud rate that is applied through the clock signal, that is receive clock is the baud rate at which the data is received. So once the data is received into the shift register, then it is transferred to the S buffer read-only register, so that the programmer or the user can read the data from the S buffer register. So we cannot directly read the data from the shift register. So it is transferred to the S buffer register, then it is read from the S buffer register. So while when the data is available in the S buffer register, you can receive another character to the shift register. But once the character has been received to the shift register, then the data in the S buffer is lost. So this is the block diagram of the 8051, and you can transmit, that is after the data is transmitted completely, that A flag is set, and similarly once the data is received completely, then RI flag is set. In case if you are operating in modes 2 and 3, then additional 9th bit is transmitted through the TB8, and additional 9th bit is received in the RB8. Now let us look at the different modes of operations of this serial port. So the first one is mode 0 of operation. So mode 0, that is the serial data in mode 0 is said to be, it operates in a half duplex mode of communication. That is only here one line is used for both transmitting and the receiving the data, that is RxD line. So is a bidirectional, that is shown here bidirectional, that is it is used for both transmitting and receiving the data. So it is a half duplex because we cannot transmit and receive the data both at a time. Only one operation is performed, either transmitting the data or receiving the data. Only one operation is performed through one line. So it operates in a half duplex mode, and then the clock is applied through the TXD line. So once the 8-bit data is given over the shift register and shifted out, and then the baud rate is fixed for the mode 0 of operation, that is the crystal oscillator frequency is divided by the 12. So the crystal oscillator frequency for the 8051 megahertz is nearly 12 megahertz, that is 11.0592 megahertz, that is 12 megahertz nearly is the oscillator frequency. So that is mode 0 of operation, and I will look into the mode 1 of operation. So in mode 1 we are going to transmit or receive 10 bits of data. So one is the start bit, another one is 8 bits of data, and then a stop bit, and then LSB is the first. So these are the 10 bits that you are going to transmit and receive in the case of mode 1. So that is one is the start bit 0, and then 8 data bits, and then a stop bit. So start bit is used to indicate the start of the data transfer, and then you transmit the 8 bits of data, and then a stop bit is used to indicate the end of the data transfer. So on receiving the data completely, the stop bits goes to the RB8 in the SCON register. So in the mode 1 and 3 we know that the baud rate is variable, whereas mode 0 and 2 the baud rate is fixed. So for a variable baud rate we should load some proper values into the timer. By loading different values into the timer register, we can select different baud rates for the serial port communication. So that baud rate is determined by the timer 1 workflow rate, and the timer 1 clock is programmable, that is it can be a 1/32 of the mission cycle or 1/16 of the mission cycle. So you can select the timer 1 clock as 1/32 or 1/16 of the mission cycle by using the S mode bit in PCON register. So that we know that PCON in PCON register, S mode bit, that is the most significant bit, is used to select the baud rate. So if this bit is set to 1, S mode bit is set to 1, then 1/32 is selected, that is the double baud rate is selected. If it is set to 0, then 1/16 is selected, and then emission cycle frequency is 1/12 of the crystal oscillator frequency. So that is shown here clearly. So the oscillator frequency is, we know that the oscillator frequency is 11.0592 MHz, that is divided by 12 is the mission cycle frequency. So for a mission cycle you have 12 clock cycles. So if it is divided by 12, you will get the mission cycle frequency as 9 to 1.6 kHz. So this mission cycle frequency is divided by 32 or 16 by the UART to generate the baud rate for the timer through the timer. So this is the mode 1 of operation in the serial port, and now let us look into the mode 2 operation of the serial port timer. Serial port. So in mode 2, 11 bits were transmitted, that is mode 2 and 3 is the 9-bit UART. So that is an additional 9th bit is used in the mode 2 and mode 3. So in total you will get 11 bits that may be transmitted or received in the mode 2. So one is the start bit and then 8 bits of data, then stop bit, and an additional 9th bit is used here. So this additional 9th bit can be a parity bit. So you can use an additional parity bit along with 8-bit data and start and stop bits. So on this 9th bit is transmitted through the TB8 pin. So you want to transmit the 9 bit, then it is stored in the TB8 before transmission, and after receiving the 9th bit, that is stored into the RB8 of the SCON register. And we know that mode 2 also the baud rate is fixed, so you can select the fixed baud rate for mode 2, that is either 1/32 or 1/64. So you can select 1/64 if you set S mode bit in PCON to 1, and you can select 1/32 if you set the S mode bit in PCON to 0. So that is about mode 2 of operation. And if you look into the mode 3, so mode 3 of operation is very much similar to the mode 2 of operation. That is in mode 3 also we transmit 11 bits of data, and but only the difference is that it has a variable baud rate. Mode 2 baud rate is fixed, whereas mode 3 baud rate is variable. So you can select a variable baud rate by writing proper values in the timer. So you can see that the timer values for different baud rates are shown here. So for example, if you want a baud rate of 300, then you need to write a value A0H to the TH1. That is you need to use the mode 2 of the timer modes. So timers are also operates in 4 modes. One is 0, 1, 2, 3, and mode 2 is the 8-bit auto reload timer mode. So in this 8-bit auto reload timer mode, if you load some value into the TH1, it is automatically loaded into the timer TL, so that it is used to generate different baud rates. So you can load different values to get a different baud rates, and so these are the 2400 and 9600. These are the standard baud rates at which the data is transferred. And then the programming the CRT serial port, that is UART, through the following steps. That is, first you need to write the PCON value, that is you need to set the S mode bit based on the mode that you want to operate, that is mode 2 and 3, and then initialize the timer for modes 1 and 3. Whereas for modes that is you need to select the baud rates for the modes 1 and 3. Whereas for modes 0 and 2, the baud rate is fixed, that is obtained through the internal crystal oscillator. Whereas for modes 1 and 3, the baud rate is variable, so I need to set some values to get the mode 1, mode 3 baud rates. And then you can use the 9th bit. If you are working in modes 2 and 3, then 9th bit need to be written to the TB8. If you are not working on 2 and 3, then it is not required. Then you need to write the SCON value to set the serial port of operation, and then you can transmit or receive the data. So these are the steps to be followed for writing the programming for the serial port. And then if you want to transmit or receive the data using serial port, some of the instructions that are used is shown here. So whereas if you want to transmit the data to the serial buffer register, then you can use an instruction called move here, move sbuff hash D. So where D is the ASCII value for D is the ASCII value, and that value is 44H, and that 44H is loaded into the serial buffer in this case. And move sbuff comma A, whatever the value in the accumulator is stored into the sbuffer register. So this is how you write the values to the sbuffer register to be transmitted. And then move A comma sbuff. So you can read the value of the sbuffer and then store it in the accumulator. So this is how you read the value from the serial buffer and store it in some register destination value. So this is how we work on the serial ports of the 8051.